Understanding sleep-disordered breathing. A good night's sleep is essential for your health and well-being. Sleep is a time of restoration for your body. While you sleep, your cells are awake, repairing themselves. Sleep-disordered breathing, or SDB, is one of the main causes of poor sleep. ResMed has created this presentation to help you understand more about the common types of SDB events, what these are, how they occur, and what effects they may have on your health. Breathing brings air into the lungs so that oxygen can be transported throughout the body via the bloodstream. Oxygen is vital for organ function and general health and well-being. If you have SDB, airflow to your lungs periodically decreases while you sleep. Changes in the upper airway are the most common cause of reduced airflow. If you have SDB, the patency or openness of your upper airway keeps changing as you sleep. It may be fully open. It may be narrowed to some extent, which we call flow limitation. It may vibrate, which is heard as snoring, or it may be completely blocked. This is called obstructive sleep apnea, or OSA. During this presentation, you will be able to see and hear how these changes affect your body. But first, let's take a closer look at normal breathing. Normal breathing during sleep occurs in a familiar, regular cycle. Its characteristics can be monitored in a sleep clinic. The technician usually attaches various sensors to the body. These help monitor airflow through the upper airway, respiratory effort, audible noise, heart rate, oxygen level in the blood, and electrical activity in the brain. The signals you will see and the sounds you will hear during this presentation are like the ones used to assess your breathing during a sleep study. When you drift off to sleep, most of the muscles in your body relax. However, there are exceptions, such as the diaphragm and, to a lesser extent, the dilator muscles, which control the tongue and soft palate. The diaphragm is assisting our simulated model to breathe normally. The dilator muscles, too, are at work, holding the upper airway fully open. As air flows freely and evenly into and out of the lungs, a typical bell-shaped curve of the airflow is seen. The air flows because of the bellows effect of the diaphragm muscle, which sucks air into the lungs. The respiratory bands attached to the chest and abdomen are measuring the effort required to breathe. They produce two traces, which rise and fall along with the airflow trace. Notice how the airflow and breathing effort traces move in sync. You can actually hear these correspond to the sounds of our model breathing in and breathing out normally. When you are sleeping normally, your heart rate is stable, the oxygen level in your blood remains high, keeping up a normal supply to all your organs. As this EEG trace shows, brainwave activity is as it should be during normal sleep. Normal breathing provides adequate oxygen supply so that all the organs can function effectively. You move naturally through the different stages of sleep and get a good night's sleep. You awake refreshed in the morning and are more likely to remain energetic during the day. Flow limitation. What is really happening? For those who have SDB, the muscles in the upper airway begin to relax during sleep, and the tongue and soft palate move closer to the back of the airway. This usually occurs if you are lying on your back or side due to the force of gravity. As the airway gradually narrows, it limits the rate at which air can pass through. We call this flow limitation. The airflow curve now has a characteristic chair-like shape. The middle of the curve looks flatter than it does for normal breathing. The flow at this point is being limited by the restricted airway. As these breathing effort traces show, our model is working harder to breathe. despite the flow limitation, the sounds of breathing are still fairly normal. From breath to breath, as flow limitation continues, the oxygen level in the blood remains quite steady and the heart rate remains fairly stable. At some point, the increased work of breathing against flow limitation may lead to an arousal. An arousal is a disturbance in the sleep cycle. This may be accompanied by some movement. There is a visible increase in brainwave activity and heart rate. Each arousal has a powerful effect on your body. On arousal, our model quickly takes a few deep breaths. As muscle tone returns to the tongue and soft palate, the airway opens. The airflow trace returns to the normal bell shape, although an amplified one. This flow limitation arousal sequence may occur several times every hour. Although there may not be much change in the sounds of your breathing, your partner may notice you tossing and turning restlessly. You may wake up feeling tired. The effect on your body is strong enough to disturb your sleep and prevent you from getting the real rest you need in order to be healthy. Flow limitation with snoring. What is really happening? In many people with SDB, snoring may occur along with flow limitation. As the muscles in the upper airway relax, the soft tissue begins to vibrate when you breathe. This creates the audible sound of snoring. The tendency to snore increases when you sleep on your back. It is also affected by other factors, such as taking certain medication like sedatives, consuming alcohol, or general tiredness. Notice the turbulence on the airflow curve. Breath by breath, the frequency of the upper airway vibration increases along with the loudness of the snoring. Snoring also increases the effort required to breathe. And it can be rather noisy. Flow limitation with snoring often leads to arousal. Once again, we see why such disturbance during sleep is a matter of concern. It has a significant, visible and measurable impact on your heart rate and brainwave activity. On arousal, our model rapidly takes a few deep breaths. As he does so, the various characteristics begin to normalize again. Whenever an arousal occurs to restore normal breathing, it interrupts your sleep. Because of the noise that accompanies snoring, most partners can readily identify this type of sleep-disordered breathing. Apnea. What is really happening? When the airflow drops to below 50% of normal, this is known as an hypopnea. If you have SDB, the amount of flow limitation you experience, with or without snoring, varies continuously during the night. As the muscles in the upper airway start to relax, the suction effect of each inward breath tends to draw the soft tissues down towards the back of the airway. Over a series of breaths, the airway progressively narrows and the airflow decreases. There are times when airflow stops completely because the airway is blocked. This is known as an apnea. Air supply to the lungs is interrupted during an apnea. Our model shows obvious signs of an apnea event. The airflow trace changes to a horizontal line for the length of time that the apnea persists. This demonstrates that there is absolutely no airflow, as our model struggles to get air through the collapsed airway. There is no noise at all, which is a particularly dramatic change if the apnea follows snoring. Our model has stopped breathing. An apnea can continue for 10 seconds or more, and in severe cases, for up to a minute or longer. During this time, the heart rate drops significantly. So does the level of oxygen in the blood, since no fresh air enters the lungs to replenish the depleting oxygen. The brain soon realizes that the body is struggling. That is why an apnea always triggers a strong arousal. with severe effects on the body. Our model gasps for air, causing a sudden movement in the noise tracks. Brain activity increases significantly. The heart rate after arousal is almost double what it was during the apnea. Our model's rapid breathing increases the airflow and the blood oxygen level begins to rise again. The tongue and soft palate quickly return to their normal position as the airway opens fully. The airflow curve returns to the normal bell shape. With every arousal, your body may move to another position in the bed, but you will probably not remember waking up, even if arousals occur hundreds of times each night. Your partner is likely to notice your apneas and arousals, mainly because, together with snoring, they are keeping him or her awake. Apnea arousal cycles produce significant stresses to your body. As you have seen, apneas cause depletion of oxygen supply to vital organs, including the brain. Arousals literally jolt the cardiovascular system. People with severe sleep-disordered breathing have poor quality of sleep. They may rarely experience the normal sequence of light and deep sleep stages which are necessary for healthy sleep. Generally, people who have SDB are often excessively sleepy during the day. They easily fall asleep at work, while driving a car, talking, reading, or watching television. Sleep deprivation can make them especially irritable. Research has shown that untreated SDB may also have other more serious consequences, such as high blood pressure, serious heart conditions, sexual problems, impaired memory, impaired concentration, intellectual deterioration, depression, morning headaches, and accidents due to sleepiness and fatigue. The good news is that it is possible to effectively treat SDB in order to get healthy sleep and enjoy a healthier life.